What we just saw in the slides was a set of ways to solve trig equations. I think it's an important thing for you to realize that you can milk information from the algebra or from the graphical representation of the functions involved to come up with a solution. Now the last example slide was the equation cosine x plus x equals 2. That's pretty much hopeless to get at by applying trig identities or facts like that. But if you think about the left-hand side and the right-hand side of that equation as representing two separate functions, and the equality in the equation as making a claim about where the functions match up, you can use a graphing utility to come up with a solution. This is the graphing utility I've been using for the demonstrations and have made available to you for tests and things. If you really prefer, you can do it on a graphing calculator as well, but I think you'll find that this is a lot easier to use. So we're trying to solve the equation cosine x plus x equals 2. So let's make f of x equal the left-hand side of that equation. So cosine of x plus x. If we graph that, before I hit the button, you might anticipate what that's going to look like. Cosine x, you know, oscillates. It's the harmonic function up and down. And x is constantly increasing. It is y equals x is just that diagonal line that cuts up through quadrant 1 and back through quadrant 3. So put those together, add them up, and you get something that has the upwards motion of x, y equals x, but it doesn't go up smoothly. It has an oscillation in it that comes from the cosine x term. You know, you talk about sometimes look at your parents and you decide, well, I look more like my mom or I look more like my dad. You can look at the graph of this function cosine x plus x and see both pieces in it. You can see the cosine x part and the x part. Anyway, so f of x is cosine x plus x. Let's make that match the right-hand side of the equation. The right-hand side is just a constant, 2. So when I graph that, that blue line is going to be graphed and it's 2 units up because that's the constant function y equals 2. Now if you click on the graphing window, that little black dot moves to help you find a point. It traces points on the curve. Here it's tracing the point on the red curve by doing the left and right arrows. You can try this when you load up this and do it yourself. And if you click the up and down arrows, it changes, it makes that point pop from one graphed equation to another. So here it is on the constant down arrow, and here it is on that red line. And you see where the point of intersection is, and you get a value that's pretty close. Now what you can do is let's do a drag box zoom in to get a little closer to that point of intersection. And again, to get even closer. And what happens is, if you look at where we are, the values that dot are running through now are very much, the upper digits aren't affected very much, and you can kind of zoom in and get closer and closer. Depending on your patience in zooming, you can get real close. Here we come. So you can see where that point of intersection is. It's not surprising that the y-coordinate should be 2 because that's on the blue line, and that's the constant value 2. But on the red line, that sort of tells you where the x-intercept is, and now we've got a number that's pretty close. It's close to 3, but it's definitely not the number 3. It's 2.98 something. You can tell that by watching it go back and forth. So anyway, if you've got access to a graphing utility, you can solve equations, at least approximately, that you would have no hope of coming up with a closed form exact solution for in terms of maybe an angle being a multiple of pi or something. So this is really a useful tool, and understanding it gives you good insight into this function approach to understanding mathematics and its applications.